Hello and namaste. We are going ahead with the double integrals, and under the change of order of integration, we are dealing with the part 3 of the change of order of integration. Change the order of integration from 0 to 4, integration from square root of 4x minus x square to square root of 4x of the function f of x comma y dy dx. If you'll observe here again, we have to understand that this part, the variables are two variables are given, that is x and y. Out of that, the inner integral, if you check the inner integral, it is depending on the variable x. That means this particular in the integral we do not have the variable y, or it is y missing. Therefore the inner integral is for y equals to this. Similarly, the outer integral is remaining variable, that is x is equals to 0 to 4. Now if you check about this particular all the curves 1 2 3 4, so if you talk about the first curve, that is y is equals to square root of 4x minus x square, it is nothing but x square, taking the square of both the sides, is it x square minus 4x plus y square is equals to 0. Making the perfect square of this particular x square minus 4x, so plus 4 minus 4 will give the perfect square of this. Taking this, we can go ahead with x minus 2 the whole square plus y minus 0 the whole square is equals to 0. That gives us the circle with the center at 2 comma 0 and the radius is equals to 2. Similarly, going ahead, that means we are going to get something like this type of figure. We are going to get it, a circle with center at 2 comma 0 and radius 2. Similarly, we'll go with the upper limit, or the upper limit of the lower the inner integral, that is y is equals to square root of 4x, parabola symmetric to x-axis, which is the parabola which is a symmetric to x-axis, will be having something like this figure. Third is x is equals to 0, that is a y-axis, so this is nothing but a y-axis of this particular third curve. And the fourth curve is x is equals to 4, which is a line parallel to y-axis and passing through x is equals to 4. So this is the x equals to 4 line. Combining all this, that means what we will be having, the region bounded by circle, parabola and the line x is equals to 4, along with the y x is equals to x0, that is a y-axis. If we'll plot all of them, okay, before plotting them, let us find out what are the point of intersection of these curves. Now if we'll talk about the points of intersection of the circle and the parabola, we can have x square plus y square minus 4x is 0 and y square is equals to 4x. That means we can go ahead and check, or you can replace this as a 4x. So x square plus 4x minus 4x is equals to 0. This gives us x square is equals to 0. This gives us x is equals to 0. So if we put x is equals to 0 in this case, we'll be getting y is equals to 0. This gives us x is equal x and y, or otherwise you can check it here. 0 comma 0 is the point of intersection of these two curves. That means the circle and a parabola will meet each other at the origin, and that is the only one intercept we have for this particular two curves. Similarly, we'll talk about the y square is equals to 4x and x is equals to 4, that is a parabola and a straight line passing through x is equals to 4. We can easily check that y square is equals to 4 into 4, that is equals to 16. That is y is equals to plus or minus 4. That is, if y is 4, then x is 4, because this is the line which we are talking about. That means we have got the point 4 comma 4 as one of the point. Another point is 4 comma minus of 4 is another point of intersection of the parabola and the straight line x is equals to 4. And if we plot all of them in one graph, we can get it the particular graph as, so this is a circle is x square plus y square minus 4x is 0. This is the parabola, y square is equals to 4x, and the point of intersection, or you can say that the line x is equals to 4 is this line, which is the line passing through x is equals to 4. Again, we can check that the center of the circle is 0 comma 2 and the radius is 2 unit, and that's the reason this particular point is nothing but 4 comma 0. So we got the point P 4 comma 0, Q 4 comma 4, Q dash is 4 comma minus 4. These are the two intercept, or you can say the intercept of the parabola and the line x equals to 4. And similarly, if you check that 0 comma 0 is one of the only, or origin is the one intersection of the circle and the parabola. So this is the curve we are going to get it. Now again, we can check it here easily, that this particular curve or this particular integral is given to us first with respect to y. So inner integral is y, and then the outer integral is for x. So we have to consider a strip parallel to y-axis over here. So we have considered a strip parallel to a y-axis as a dash and b dash. So a dash, the lower end is on the circle, upper end is on the particular parabola. Therefore, this is the area, or you can say the restriction, or the outer integral is moving from x is equals to 0 to x is equals to 4. So we can easily check that the region is lying somewhere here in this particular strip, and out of that the lower end is on the circle, upper end is on the parabola, is this region which I have shaded in the blue color, is the region of required region for this particular integral, or the given region for this integral. Now we have to change the order of integration. That means we have got this particular strip is parallel to y-axis. We have to make this strip parallel to x-axis, and we have to check what would be the integral of that kind of figure. Now moving ahead, so we can easily check that to change the order of integration, that is to integrate first with respect to x. Now whenever the given integral has been given to us, that is like integrating first with respect to y. Now we have to change the order. That means we have to first integrate with respect to x. So divide the region into three sub-regions: ORT, TPS and RSQ. And why this has been dividing into three different regions? The reason is every time this end, or you can say the left end and the right hand side end of the curve is changing about these points. So this is nothing but draws a horizontal strip parallel to x-axis in each sub-region. If we'll talk about the green part, or you can see this particular part, which is this part, ORT, this green part. So this AB starts from the parabola y square is equals to 4x and terminates on the circle. So this particular parabola AB is starting from, or this strip is starting from the parabola to the circle. So the limits of x is equals to y square by 4 to x is equals to 2 minus square root of 4 minus y square. Because this is the center of the circle is 2 comma 0, and therefore this particular part is less than the 2, and therefore this part of the region or the circle is been divided, or can be written as 2 minus square root of 4 minus y square, and therefore this is x is moving from the left hand side of this circle to the particular part. So therefore this is nothing but 2 minus square root of 4 minus y square, part of the circle where x is less than 2. So it's very simple to understand where the x is moving less than 2. Limits of y is nothing but y is moving from this the x is equals to 0, y is equals to 0 to till this point where the y is equals to 2, and therefore 0 to 2 is the limit for y, and therefore this particular integral, this is just a part I1, is nothing but integration y equals to 0 to 2, integration from x y square by 4 to 2 minus square root of 4 minus y square, f of x comma y dx dy. This is just a first region, which is the green region, Next, if we talk about the region which is in yellow color, or you can say that TPS, this region. So we have got the strip CD is the strip which is starting from the circle. So we have to check the left hand side end and then the right hand side end of this particular strip CD. So C point is lying on the circle, which is this circle, and the terminates at the line x is equals to 4. Therefore the limit of x is equals to 2 plus, if you observe here, this is nothing but the center of the circle is 2 comma 0, and the points, all these points are on the circle are lying greater than 2, and therefore this x is moving from 2 plus square root of 4 minus y square to x is equals to 4, which is a line parallel to y-axis. Similarly, limit of y is nothing but, if you observe here, the limit of y is from this case is again moving from 0 to 2, and hence this is, you can check that this is I2 say for. So integration 0 to 2 from y, and then integration of x is equals to 2 square root of 4 minus y square to x is equals to 4, f of x comma y dx dy. So we are integrating this with respect to x first and then with respect to y. Moving ahead, towards the pink color, this particular region, which is nothing but RSQ. This is the region, and we are considering a strip EP over here. EF is the particular strip which is starting from the parabola. So this end is of the strip is starting from the parabola to the line x is equals to 4, which is terminating at the line x is equals to 4, and therefore the limits is moving from x is equals to y square by 4 to x is equals to 4, and the limit of y is moving from this 2 to 4. And therefore this integral can be written as, say for I3, it can be written as integration y is equals to 2 to 4, integration from x is equals to y square by 4 to x is equals to 4, f of x comma y dx dy. And if we'll combine all these three, or the given integral I can be written as the addition of three of them. Whatever we have seen, the green color, pink color and the green color, yellow color and the pink color, or whatever the integrals we have taken the last two slides and this one, can be the change of order of integration of this particular question. Yeah, and this is all about this change of order of integration part 3. This is a different question. Again, this is a little difficulty level is little more than the first and second part. I hope you have understood the change of order of integration in very well. Thank you. Happy learning.